So this is going to be the second last video as of right now from what I'm thinking, and this video will cover how to actually produce the walls, how to create a completely random maze out of thin air. Or not completely, but close enough. And in this video you'll learn about randomizing values and instancing scenes, and that is very useful in creating your own game if you continue using Godot, which I hope you do. It's a great engine. And as you can see in my game, in my scene tree, if you remember what that is, it's this. It looks a little different than yours. And I went ahead and created everything beforehand. So I want to take us on the videos, because I noticed that the videos are kind of stretched out. So to prevent that, let's just move on. And I created a spawning platform for the player, and that's just a mesh with a static body, and I set the collision layers on 2, or mask 2. And you should know how to do that. You created the floor. And next, I added a wall holder, which is just a normal Node 3D. You should know how to instance or create a new Node 3D by now. If you don't, it's Control A. Okay, so that's not all I did. I added a script to maze, and this script should be within the world folder, right? And there's a decent chunk of code. Now I used an inbuilt function, as you can see, for this process, same as the function we used in the player script. So the first thing you notice when you look at the script, extends Node 3D, covered that. It's just a normal Node 3D node, so it's not going to have character body 3D like the player. Instead, it'll have Node 3D. And just a quick reminder, everything that the Node 3D does have, the player will also have, as it's a kind of like a child of the Node 3D. If I go to physics body, you can see how it's like kind of under its branch. Anyways, so this is what you'd call a preload, and preload is just you get the scene inside your code, inside a script, and you essentially load it. So if I were to open, let's just say I download a video, for example, and now I want to send all the videos to my friend. First, I would have to download the video before I obviously send it to my friends, and that's what we have to do in the game too. So we're gonna load in the wall scene. There's also a load kind of method, but I'd recommend using preload as it's more optimized for what we're doing, at least. Now I put the floor size as 300, and that's because, as you can see on the right, the property is 300 on the X, 300 on the Y. So I just put that in as 300, and I'm assuming that your floor is also a square. If it's not, then you're going to create another variable called for the X and Y, and implement that in. It wouldn't be that hard, I can tell you once we get there, but then I created 3 export variables. And if you really want to, you don't have to make these export variables. I just prefer having them because I could change them with ease, and I think it's just fits better. Anyways, the max walls will obviously determine how many walls we want. The minimum scale will tell us what's the minimum scale we want our wall to be. Because if you remember from last video, we added a function in the wall script, in the wall scene, which I'll show you later, because I should show you now, I guess. This function, I'll go for everything else for this line of code, and it just scales it on the x-axis by a certain amount from the parameter we put in. Okay, where were we? And the max scale will determine the maximum. Alright, so in the physics process, you notice we have the delta parameter by default, and I set a keybind to spawn in a maze. If you really want to, you could also do this in function ready and just copy in all of these lines of code to function ready. But I wanted to show you guys that it actually is random. So, you know, I did this, and so I have a print statement. I know usually you start a programming course, you do hello worlds, right? But I feel like that's all kind of useless, so I kind of skipped that in the first video. But anyways, this print statement just verifies that we press E, and you'll notice it in the output. So in over here, this line number 16, you notice a randomize method. In the randomize method, basically it tells our game that we want to reset the seed of what is actually random. So if you've ever played, it's kind of a silly example, Minecraft, you have a world, right? Every block is going to be the same block if you use the same seed. But if you switch up the seed, then every block will be completely different almost. And that's essentially what this does. And you can control click on anything, any of these methods if you want a better description. But all it does is, if you're gonna have something that's random come in multiple times, then you're gonna need that. And then we use a for loop. And to write a for loop in Godot, you need what you're iterating through. So for this for loop, we're iterating through the max walls divided by 2, and I'll tell you why in a bit. And then what each iteration will be called. So I put it as W because I'm going to create a variable called wall in a second. So that's why I use W. But basically, since our max walls is set to 20, these lines of code will be called 10 times in total. And if you look over here, this is how we actually instance a scene. Now, instancing a scene is the same as pressing Ctrl-Shift-A and adding a wall normally, except you do it through code instead of the editor, which a lot of the cases is more useful and more efficient sometimes, surprisingly. And whenever we instance a scene, we have to add it to a parent, right? And otherwise it won't be part of the C tree. So I created a node 3D called a wall holder, as I explained before, and I added each wall as a child to the wall holder. Now you could add it to anything you'd like, except do not add the wall to something that's moving, like the player, because then the player will move the walls with it, and you won't ever come in contact with the wall. And these two lines are basically to randomize the position of the wall. So to get the position of the actual wall, so to get the property of the wall, we use global transform.origin. And if you look at a player, the origin would be the middle of the player. Okay, and I don't think I've mentioned this before, but you can use WASD to move around the editor and scroll wheel to increase or decrease how fast you move. It's pretty useful. I like it better than using this thing. Anyways, I forgot what I was saying. Okay, sorry. So the random, basically what this method is random int range. So the I stands for integer, and this obviously stands for random, and the range makes you input a range of what you want. So okay, I'll give you an example. So range 0 to 3. This will give me a random number from 0 to 3. And the reason I like to do range is because if we do range I, which is a random integer, it could give us 5 billion, it could give us negative 5,000, it could give us really anything. So we do not want that. We want our walls to be on the actual floor, so we can actually, see them and bump into them. So we do that for the x-axis, and then we do it for the z-axis of the wall. And we do negative floor size divided by 2 because if you look at our floor, it's in the middle of 4 quadrants. And if you passed math class, you'll know that there's quadrants, like this is quadrant 1, this is quadrant 2, and blah blah blah. But this is the origin, right? This is 0, 0, 0. So 3 zeros, and it can go from, so basically the moral of this is we have negative, so we have 150 this way and 150 this way, and negative 150 to be precise over here, and 150 over here, and it would be the same for the x-axis. So we can't do 300 because then we'd have walls spawning over here and over here, or just here, or whichever way is positive. And it's the same with the x-axis. So each of these squares is 150 by 150, which is y. We need to do negative 150, and then click on the wrong scripts. Okay, so negative 150 to negative, or 150 on the x and z axis, and we're not doing the y because we don't want floating walls. That was the purpose of maze. And then, just because we want it, we can change the wall size. If you want all the walls to be the same size, you're free to exclude this and just set the default wall size in your scene. We call the random range again. We pass in our min and max scales, which we set, or which are export variables, which we can change. And again, it's just adding scale. And because I thought it would be boring to just have horizontally straight walls, I thought it would be good to rotate them 90 degrees on the y-axis, so you can, like, I don't know, it's just a better maze, I guess. It would be harder to escape. And every single line of code is the same except for 26, where I used a new function within the wall scene. I can click on that, or I can go to that. So I just called the wall.rotateWall, and rotate wall is simply just rotation degrees.y equals 90, and that's because if you can see in the bottom left, something's about to pop up. As you can see, it says rotating blank degrees, and that just tells us that the editor by default uses degrees. So that's what we also want to use. And because no one uses radians, not just be a pain. Okay, so we have that down, and that's practically all it is for the spawning in the walls. This is a beginner tutorial, right? And anything more complicated than spawning in random tutorials would take like 10 more hours than I need to, and it'd be way too confusing. So this is the best we're gonna get. You can see there's nothing spawned in yet. I'm about to press E, all the walls are gonna spawn in. So press E, a bunch of walls spawn in. As you can see, there's a bunch of walls. And now I want to make, okay, you can also see I didn't add static bodies just because if the maze is not possible. But I can press E again if I don't like how the maze looks. And I'll add more walls on top of these walls. If you want to, like, I'll show you examples. So now there's more walls, but the same walls are still there. You add more and more and more and more and more and more and more. But if I want to reset the maze completely every time, all I'd have to do is do for, well, actually before that, let me explain what these green things are. So in the player script, we used onReady variables, right? And you notice that these green things are there. And in normal scripts, if you just want a quick reference to a node that's already within the scene by the time you're in the editor, you can just do $, and then type in the node name, wall holder, and they'll appear. If you went to like collision shape on the floor, right? I can just get the collision shape. So it's another way, it's an easier way instead of doing onReady. If you're too lazy to, I don't know, if you just want to clean your script, there's really no need. You could just use onReady if you like, but since I'm really calling this twice, I just thought that it wouldn't matter. And back to what I was doing before, all we're going to do is do for C for child in wall holder dot get children. So this is going to give us all the children that are under the wall holder. So all the walls basically. And Then we can loop through each child, which is going to be C. So C is going to be the child. So we're going to do C.Q3. If you're wondering what that does, it basically deletes it safely. So for every child of the wall, we're going to safely delete it. If I want to read up about that, just this. Yeah, and get children, just an array of children. And I know we didn't go over that much. But I'm planning on creating a new series, because if I'm being completely honest, I don't think this like game idea covers like a decent amount of fundamentals. So I recommend you subscribe. Same shameless plug, but I'll be creating better content. This is like kind of a test run for me, where I want to choose like what type of videos I think are more enjoyable for me to create. So I find this pretty much better than creating normal tutorials. So I thought I'd make a better version of this, but instead of creating a different game. I have no clue what the game is going to be, yet, but it'll be something more interesting. Anyways, okay, so it should work now. I press E. Let's just go through the maze a bit. As you can see, there's a bunch of walls kind of clipping into each other, but that's fine for now. Yeah, looks pretty cool. We have our maze. Now let's spawn in somewhere. So you can see all the walls got deleted, and they respawn with more. And if you want to add static bodies to the wall, again, you just click this mesh button and then click create trim static body and change the collision layer to 2, or mask to 2. And that would be simply it. So actually, that's not true. This is a little more complicated. Just to create trimmage collision. And that's all it does. I don't know why I said complicated. It's just one line of code. However, I'm not sure how it does it. Okay. So yeah, the collisions somehow work. And I can go through the walls. And I can sprint really fast. Forgot about that. So yeah, this is the maze that we've been working on, and